Hello grade 11 and grade 12 chemistry learners. In this video we're going to be looking at the quantitative aspects of chemical change, which is also called stoichiometry, and we're going to be focusing on past papers that look at limiting reagents, how to determine which reactant or reagent is the limiting reactant or reagent, how to calculate the mass or the moles of the excess reactant or reagent, things like that. Let's jump right into the video. This is the first question that we'll be looking at, and as you can see, they ask us to define the term limiting reagents. Then they want us to determine the limiting reagents, so figure out which of those two reactants are the limiting reagents. Then they want us to calculate the mass of the other substance that's in excess. So remember, in a chemical reaction, if you have a limiting reagent, that's the one that is going to be consumed completely. It's going to run out first. Your other reagent or reactant will be in excess, which means you have over enough of it, which means that after the reaction is complete, there will be some of it left over. So as you can see in 6.3, they want us to calculate the mass of that substance that's left over or in excess. And then they want us to calculate the volume of CO2 produced at STP. In other words, they want us to figure out how much product is produced. So let's jump right in, 6.1. Now the definition of a limiting reagent is the limiting reagent in a reaction is the reactant that is consumed completely. What that means is that it is used in its entirety. There's not a drop of it left, there's not a gram of it left, there's not a mole of it left. All of it is used up completely. It runs out first. And, very important, it determines the maximum amount of product that is made. Now, when I explain this, I like to use this example. So let's say I have sausages or Viennas and I have hot dog rolls. And as I know, or as you know, if you add one sausage into one hot dog roll, we make one hot dog. Now, if I have 1, 2, 3, 4, 5 sausages, so let's label them 1, 2, 3, 4, 5 sausages. And how many rolls do I have? I have 1, 2, 3, 4 hot dog rolls. Ignore the product for now. Ask yourself, how many hot dogs can I make in total? And we're going to assume that you can only make a hot dog by adding one sausage on one roll. You can't cut up the sausages. You can't do anything weird like that. So you add one sausage to one roll. So that sausage will go there. That one will go there. That one will go there. That one will go there. And I will have one extra sausage. So what I'm trying to say is that my sausages are in excess. I have over enough sausages. They're not going to run out. When the reaction is complete, or when my recipe is complete, I'm going to have extra left over. Here you can see the little sausage. The rolls are limiting. What that means is they will run out first. So if you're making hot dogs, you're going to run out of rolls first. The hot dogs are the limiting reagent. Let's go back to our definition. It's consumed completely. All our rolls will be used up. And it determines the maximum amount of product that can be made. So because I have 4 hot dog rolls, the maximum amount of product I can make, the maximum amount of hot dog rolls I can make is 4 hot dog rolls. I can't make 5 because I ran out of rolls. So it's very important to note that the limiting reagent determines the amount of product that can be made. And that is why if we take a look at our questions, when we're working out the volume of CO2, CO2 is our product. So when we're working out the amount of product later, we will be using our limiting reagent to help us find this. Because remember, it's the limiting reagent that determines how much product we can make. But now, how do we determine the limiting reagent? Well, if they want you to determine the limiting reagent, it's because you have 2 reactants over here. So we've got this, which is ethanoic acid. This is an acid. And they add it to sodium bicarbonate. So those are my 2 reactants, and they give me information about both, but we don't know which one is going to run out first. So if you take a look at the question very carefully, we can see that in terms of our acid, this is ethanoic acid, they tell us that we have 100 moles, that's the volume, that's the same as 100 cubic centimeters, and the concentration, 0.2 moles per cubic decimeter. That is the information they've given me about the acid. But they also give me information about sodium bicarbonate. They tell us that our sodium bicarbonate, we have 10 grams of sodium bicarbonate. So basically what's happening here is they're giving us information about both. They're not telling us which one is in excess. They're not telling us which one is limiting. Now we have to do something with this information in order to figure out which one is limiting. And these are the steps that you follow. First of all, we need to make sure we have a balanced equation. Then we're going to convert the given information for both to moles. So we were given information about the acid. We're going to convert that to moles. We were given information about sodium bicarbonate. We're going to convert that to moles. Then we're going to write down the mole ratio. And we're going to choose one of these moles. And we're going to work out the other reactant's moles. We're going to analyze it to see which one is in excess and which one is limiting. So let's do this as an example. Let's do this, and hopefully the steps will make sense once I go through this. So first of all, if you look very carefully, the equation is balanced. We have, for example, 3, 4, 5 hydrogens on the left, 3, 4, 5 hydrogens on the right, 1, 2, 3 carbons on the left, 1, 2, 3 carbons on the right. And if you check your oxygens, if you check everything else, everything is balanced. So we've got a balanced reaction. Then we're going to convert the given information for both to moles. So for our acid, they give me the volume. They tell me it's 100 milliliters, which is the same thing as 100 cubic centimeters. But we know we need to convert that to cubic decimeters. You divide that by 1,000. So that is 0,1 cubic decimeters. They also give me the concentration. C is equal to 0,2 moles per cubic decimeter. If at this stage you're still unsure as to how I knew that this was volume and this was concentration, you need to realize that you need to understand your units. So milliliters, liters, cubic centimeters, cubic decimeters, that's all an indication of volume. Moles per cubic decimeter, that is an indication of concentration. So in order to convert this information to moles, we're going to use the equation C is equal to N over V. You write your formula as it is on your formula sheet, you substitute in, so it's 0,2. We're looking for number of moles, volume is 0,1, and we get number of moles of our acid is 0,02 moles. Now remember, that's just the moles of one of our reactants. Our steps say that we have to do it for both of the reactants. So let's convert sodium bicarbonate's information into moles as well. If you read the given information very carefully, you will see that they tell us that we have 10 grams of sodium bicarbonate, and that's the only information we have about sodium bicarbonate. Remember, the 100 milliliters and the 0,2 moles per cubic decimeter, that was for our acid. So we already converted that to moles. Now, how do we convert 10 grams to moles? Well, 10 grams is mass. They don't need to tell you that. You need to know that 10 grams is mass. In order to convert mass to moles, we're going to use this formula. Number of moles is equal to mass divided by molar mass. So that means I need to find the molar mass of sodium bicarbonate. So we take the atomic mass numbers. It's 23 plus 1 plus 12 plus 16 times 3. If you've forgotten how to do this and you need a recap, check out the links in my description. And we get 84 grams per mole. So therefore, the number of moles of sodium bicarbonate is 10 grams given in the question, divided by 84. We work that out and we get 0,119047619 moles. Now, you can leave that as a fraction, which is 5 over 42, but what we're going to have to do now is we have to think about these mole answers that we have, and we need to compare them. Now, the rule is you can't compare moles to moles directly. You have to consider the mole ratio. So what I mean by that is you need to look at the two reactants that you just calculated, the acid and sodium bicarbonate, and you need to consider their mole ratio. Remember, the mole ratio is the big numbers in front of these compounds over here. So because there's no big numbers, we see that it's a 1-to-1 ratio. What this means is as follows. We've got a 1-to-1 ratio. Now we worked out that we've got 0,02 moles of our acid and 0,119 moles of our sodium bicarbonate. Now how you determine which one is limiting is as follows. We take one of them. So my steps say pick a mole. So I'm going to pick this one, and you ask yourself the question, if I want to react all of this, so if I want to use up the entire 0.02 moles of the acid, how many moles of sodium bicarbonate will I need? Well, because it's a 1-to-1 ratio, I will need exactly the same number of moles of sodium bicarbonate. So if I want to use all of the ethanoic acid, if I want to use all of the 0.02 moles of ethanoic acid, because it's a 1-to-1 ratio, I need the exact same number of moles of sodium bicarbonate. But then you compare that to what you actually have. I need 0.02 moles. I have 0.119 moles. So do I have enough? Remember, I need 0.02. I have 0.119. Yes, I have over enough. I have 0.119. That's more than 0.02. So therefore, the moles of sodium bicarbonate that I have is greater than the moles of sodium bicarbonate that I need. What does that mean? If you have more than enough, remember the roles, you had more than enough. That means that sodium bicarbonate is what we call my excess. And therefore, that allows us to conclude that my acid is limiting. You have to put it in the mole ratio first before you compare it. And you might be thinking, okay, ma'am, remember that step where you said pick a mole and you picked CH3COOH. You put 0.02 in the ratio. What happens if you picked the other one? Let me show you. Now, again, we write down our mole ratio. So our mole ratio is 1-to-1 that comes from the balanced equation. And we choose these two to be in our mole ratio because we're deciding between these two. These are my two reactants. They're on the left-hand side of the equation. We want to know which one of these is limiting. So I write down the mole ratio 1-to-1 that comes from the balanced equation. And then remember in my previous option, I picked the moles of the acid. Now I'm going to pick these moles. So if I want to use up all of these moles, so if I want to use up the entire 0.119047 moles of sodium bicarbonate, how many moles of the acid would I need? I would need the exact same number of moles of that acid. Why? Because it's a 1-to-1 ratio. So this is the moles of the acid that I need in order to use up all of the sodium bicarbonate. Compare that to how much I have. I need 0.119. I only have 0.02. I don't have enough acid. I would need 0.119. I have 0.02. Therefore, the moles of the acid that I need, is way more than what I have. Or you can argue and you can say the moles that I have is less than what I need. Therefore, my acid is limiting. So either way, if you argue it, you're going to come to the same conclusion, that my acid is my limiting reagent. And that means that my sodium bicarbonate is in excess. So you have to put it in the mole ratio to compare. Now my next question says calculate the mass of the other substance in excess. So when they say other substance, they mean the one that's not limiting. So that will be our sodium bicarbonate. So basically they want to know what mass of this is left over, is in excess at the end of the reaction. In order to work out how much is left over, we need to take the mass or the moles that I start with. So the mass or the moles at the start minus, let's work with moles, minus the moles that was used up. And that will get me the leftover or the excess. So what I'm going to do is, I know the moles of sodium carbonate that I had at the start. Remember, we worked it out. We used the 10 grams. We said it was N is equal to mass over molar mass. We said it was 10 divided by 84, that we got 0.119047619 moles. This is the moles of my excess at the start. Now, how did we work out how many moles are going to be used up? Remember, the limiting reagents moles will be able to help me work out how many moles of the other one we will use up. So always use your limiting reagent to work out the moles of your other stuff that's going to be used up. And remember, we already did that. We said that if we're going to use up all of our limiting reagents, so that's 0,02, how many moles of sodium carbonate would we use up? We would use up 0,02 moles of sodium carbonate. So I wrote over here, we always use up all of our limiting reagents. So this was the moles of our limiting reagent. We're going to use all of that. We use our limiting reagent to work out how much of the other one we react. So remember, our excess one is sodium bicarbonate. We put it in a mole ratio. You always need to use your mole ratios. We put it in a mole ratio with our limiting reagents. So we use our limiting one with our excess reagent to work out how much of the excess we use up. Remember, some of the excess will be left over. That's what we're trying to work out. So if I use up all of this limiting reagent, 0,02, because it's a 1-to-1 ratio, that means that I will react 0,02 moles of sodium carbonate as well, because it's 1-to-1. And how much sodium carbonate did we start off with? Sodium bicarbonate. This is how much we started off with. Remember, that takes us back to our initial mole calculation for sodium carbonate. So if I start with 0,119 and I used up 0,02, how many moles do I have left over? You take what you start with and you subtract what we used up or what was reacted. And that equals our leftover or our excess. There we go. So we take the moles at the start, so that's what we started with. We minus or we take away what was reacted, and what is left over is the excess. So moles at the start minus what was reacted or used up, different way of saying it, and that leaves us the excess or the leftover. Now, just as a side note, if you're still a little bit confused, remember the moles at the start that we got by taking the mass that was given divided by the molar mass. So that was 10 divided by 84. That's where that number of moles comes from. The moles that was used up, this we get from our mole ratio, and we always use the limiting reagent in that mole ratio to help us figure out how much of the other one was actually reacted. And when we use our mole ratio, because it was a 1-to-1 ratio, we got 0,02 moles was actually reacted. And if we say that, so our starting moles minus 0,02, what we get, our leftover moles, the excess, is equal to 0,099046 moles. Now, the reason why I haven't rounded off is because the question, if you take a look back at the question, it wants the mass of the leftover reactant, the excess reactant. So how do you convert from moles back to mass? We use this formula. N is equal to baby M over big M. Remember, we're working with sodium bicarbonate. That is my excess. So we're going to sub in our leftover moles, 0,099, so on. We're looking for mass. Our molar mass, remember, is 84. We already worked that out. So we're going to multiply our moles by 84, and we get the following 8,32. 8,32 grams. That's the leftover. So remember, we started with 10 grams. Basically, what that means is we started with 10 grams, which is that many moles. We converted to moles. We used up 0,02 moles of that. We could also work out the grams that we used up if we wanted to. And we left with 8,32 grams. Now, if you rounded off your previous answer and instead of using 0,1190, you used 0,12 moles, you'll get a slightly different answer at the end. But remember, you may use the non-rounded off version as well. So your answer will range between 8,32 like mine and around 8,4 grams if you use the rounded off version from the last question. Now 6,4 says calculate the volume of CO2 produced at STP. Now this question is actually quite straightforward once you've worked out what the limiting reagent is. Because remember, our definition for limiting reagent is the limiting reagent determines the amount of product that is made. So once we know what our limiting reagent is, which we do, we know our limiting reagent is our acid. We use our limiting reagent, which is our acid, in a mole ratio with our product, So that mole ratio will be also a 1-to-1 ratio, luckily, because this equation is balanced. If we know the moles of our acid that reacted, which we do, it's 0,02. We worked that out already. Therefore, we know 0,02 moles of product is produced. Remember, you always use your limiting reagent in a mole ratio with your product to work out exactly the number of moles of product produced. Now we know that's the number of moles of CO2 that is produced, but they want the volume produced. So all we need to do is convert that moles to volume. So there we go, a note for you to take down. We always use the limiting reagent in a mole ratio with the product in order to work out how much product is produced. So because we are reacting 0,02 moles of our acid, and if you forgot where that comes from, remember that comes from the very beginning when we took our information about our limiting reagent. We worked out 0,02 moles. That means all of that is going to be used up. So if I'm going to use up 0,02 moles, I can work out how much product will be produced. It's a 1-to-1 ratio, which therefore means 0,02 moles of CO2 will be produced. But remember, that is the moles of CO2. And my question wants the volume. The question in particular says volume, and they say at STP. As soon as you see volume and you see STP, you know you're going to use this formula. And if they say at STP, you know that your molar volume is 22,4 cubic decimeters. We know our moles, so you substitute that in the place of moles. Then to get volume, you say 0,02 times 22,4. And we get our volume as 0,448 cubic decimeters of CO2 is produced at STP. Just remember, it's always the limiting reagent that helps us to determine the amount of product that is made. And if you forget that, just remember my hot dog example. I hope that was helpful. Check out the links in my description below for more stoichiometry videos, more help with limiting reagents, and all other sorts of stoichiometry questions. Subscribe for more. I'll see you in the next video.